Okay, gang, happy Friday. Welcome back. Today, October 27th, we are covering the chain rule and inverse functions. Today, we're going to learn the derivative of the natural log function and the derivatives of a couple of inverse trig functions, I think inverse sine and inverse tan, and then like another log derivative where the base is not e. Today is going to be the last collection of new derivative rules for the entire semester. We are going to do like another derivative technique in this implicit functions day, but there's no more new derivative rules for us for the entire semester after today. Looking ahead, on Monday, we are going to do our derivatives overview. That is to say, just take all of the derivative rules that we have built together and put them together in complicated ways, product rule, quotient rule, chain rule, and find those complicated derivatives. So that's coming up on Monday. Hopefully that will give us some insight if we're struggling with figuring out like which derivative rules do we apply and in what order do we apply them. That's what we're doing Monday. And then Wednesday is our review day for the test. And then the test itself is on Friday, a week from today. Any questions on that schedule?
Do we have a sample test in our packet?
Yeah, right at the end of the packet is a collection of sample test problems. There are YouTube videos for all those problems. Yeah. Okay, also looking at the calendar, steel drum is due right now. So before we put them in the green folders, make sure the green folders are empty. I returned the derivatives quiz in the green folder. Just take them all out before we put the projects in. So steel drum due today, pipeline is due on Monday. As usual, I will take them up to 1 week late with various penalties. So you want to turn it in as soon as you can. And I think that's it for the calendar. Oh, one other thing coming up. This won't affect our class, but Tuesday coming up, there are no day classes at GCC because advising day. So make an appointment to meet with your advisor next week sometime, maybe Tuesday. We cancel all the classes so you have time to meet your advisor. They possibly have just a blank schedule outside their door where you can write your name in a slot. Otherwise, you can call them or email them. Okay, so here we are on page 51, right at the top. Today we learned the derivative rules for log functions and inverse trig functions. Number one, last class we reviewed this fact right here. E to the ln of x equals x, right? E and ln of x are inverses of each other and they cancel in that very specific way. So what we're going to do is figure out what the derivative of ln of x is equal to by differentiating both sides of that equation up above. So let's take a derivative of both sides of that equation. So I'm just going to copy that equation here in blue. E to the ln of x equals x. Everybody believes that one. And then I'm going to take the derivative of both sides. And so if we believe the blue things were equal before, then when we take the derivative of both sides, they should still be equal to each other. Yeah? Okay. The right-hand side is easy. We'll start there. What's the derivative of x? 1 equals. Left-hand side is a little bit more complicated, but this is simply e to some stuff. Yes? We know how to handle e to the stuff. It is e to the stuff times the derivative of the stuff, which is ln of x. Yeah? Now what we are doing here in this process is figuring out the derivative of ln of x. So we don't know what it is right now, which is why I've just written symbolically the derivative of the stuff. But if we solve this equation for the derivative of ln of x, we will have created our derivative formula. So let's do it. E to the ln of x. I don't want it here. I want the derivative of ln by itself. So I will divide both sides by e to the ln of x. So that says derivative of ln of x equals, there was a 1 over there, divided by e to the ln of x. Everybody see what we did? Just divide both sides by e to the ln of x. And then we're pretty much done. Derivative of ln of x. Oops. ln of x equals 1 over, but now let's clean this up. What is e to the ln of x? X. So there you have it. The derivative of ln of x is 1 over x. There have been some derivative formulas, most of them this semester, where I have just like handed them to you and said, hey, it's true, trust me. And for sine and cosine, we looked at a graph and it was like, oh, it looks like it's true. Trust me. You don't have to trust me. There it is. We just proved, we created from scratch the derivative of ln of x. It is simply 1 over x. So let's fill in the blank in number 2. Derivative of ln of x, we've just discovered, is 1 over x, which we can then extend with the chain rule. Derivative of ln of stuff, 1 over the stuff times derivative of the stuff. And I will point out that derivative of the stuff is not on the bottom. It is tempting to put the derivative of the stuff downstairs because that's where you just put the stuff. That's not right. It's on the side, which means it's really on the top. Okay, this 1 over x is another derivative formula that cannot possibly be true, and yet it is. It shouldn't be that nice. Like, think about the graph of ln. Here it is. There's a graph of ln of x. Somehow, by some miracle, the derivative of this thing is exactly 1 over x. So for example, if I come over here to x equals 26, and I draw a tangent line right there, the slope of that tangent line is 1 over x. Slope at that spot is exactly 1 over 26. If I come over here to x equals 2, and I draw this tangent line, well, it's a little bit steeper. What's the slope of that one at x equals 2? 1 over 2. It is simply 1 over the x coordinate. It's like magic. Whatever the x is, 1 over that, that's your slope. Works even for the decimal values in here. Suppose that I were to pick this guy right here. Let's call it like x equals a third. And then I'll go down. It's really hard to see because there's a lot of action happening in a small space. But what is the slope? It's 3, isn't it? 1 over x. 1 over a third. Slope of that one is magically 3. Whatever the x is, the slope is just 1 over x. Shouldn't be true, but it is. Okay, let's use our new derivative formulas down here. Let's find the derivatives of the following. Y equals ln of x cubed minus 7x. So first, give me a good derivative symbol. For example, dy dx equals. Okay, this is ln of some stuff. How do we start? 1 over the stuff. 1 over x cubed minus 7x. I've seen some students make the mistake of putting 1 over ln of x cubed minus 7x. That's not it. The ln disappears entirely in this derivative rule. Times derivative of the stuff is 3x squared minus 7. Got to have parentheses. And again, that is not on the bottom. That's on the side, which really means it's on top. Okay, part B. Is part B ln of stuff? No. Part B is stuff to the 7th power. Okay, so let's use the other common derivative form notation. Y prime equals. So what do? 7 comes down. Copy the stuff. Now 6, subtract 1, times the derivative of the stuff in the parentheses. That's 1 over x. That's it. Any questions on ln? Okay, next page. Next thing we're going to do is create a formula for the derivative of inverse sine. This is another one of these where we're going to build it from scratch, and at the end of this problem, we're going to have something that says the derivative of inverse sine is, and there'll be a formula. In fact, you memorized it for that quiz, but let's see if we can figure out where it came from. So we are going to start this calculation with the fact sine of inverse sine of x equals x. Everyone agree? Sine and inverse sine cancel. So we believe that equation is true. So let's rewrite that equation. I'll put it here in blue. Sine of inverse sine of x equals x. And just like before, we're going to take the derivative of both sides of that equation. And if we believed the blue things were equal, then certainly their derivatives will be equal too. Okay, let's take our derivatives. Right-hand side, again, that's easy. It's just 1. Left-hand side, it looks complicated, but fundamentally the left-hand side is the derivative of sine of some stuff. Don't get lost in the stuff. It's sine of stuff. What's the derivative of sine of stuff? Cosine of the stuff. Okay, so we're right. Cosine of the stuff. What's the stuff? Inverse sine x. But then the chain rule says what? Times the derivative of the stuff. Again, what's the stuff? Yeah. Oh, we don't know that one yet. You get into the punchline there. Okay, so that's cosine of stuff times the derivative of the stuff. It's just written. Derivative of inverse sine of x. Okay, and you know what the punchline is, right? Like Ryan was starting to say what the answer is. Like you memorized already that the derivative of inverse sine is 1 over square root 1 minus x squared. That's what you memorized. It was just out of a hat when I said, hey, memorize it. But now we're going to come up with that. That is going to be the last thing we write in this problem. Okay, the goal is to figure out a formula for the derivative of inverse sine. So we are going to move this cosine of inverse sine over to the other side by dividing, just like we did in the previous problem. So here we go. Derivative of inverse sine of x, that's all that remains on the left-hand side, equals 1 over cosine of inverse sine of x. Now, in some sense, we're done. That is a perfectly good formula for the derivative of inverse sine. Now, that is not what I asked you to memorize, and that is not what you wrote on the quiz. So what we're going to do is write this thing in a friendlier way. We're going to get to the thing that was on the quiz, but the calculus is done, and the rest of this problem is pre-calculus. Okay, cosine and inverse sine. One trig function, one inverse trig function. They don't cancel because they're not the same, but they are going to work together in a particular way, and we got to figure out what that way is. Here's what we're going to do. I'm going to think of this thing right here as being cosine of theta, right? I mean, cosine naturally has an angle inside. So I guess what that really means I'm saying is that I am thinking of theta as being inverse sine of x, okay? And said another way, if I take the sine of both sides, that tells me that the sine of theta is simply x. By that, take the sine of both sides, sine of theta on the left, take the sine on the right, and it cancels the inverse sign. Okay, and hey, x is really just x over 1. And so now I'm thinking of SOHCAHTOA, and I'm thinking of a right triangle that I haven't drawn yet, but in that right triangle, I know that sine is opposite over hypotenuse, right? So there is a right triangle out there where the opposite side of the angle theta is x and the hypotenuse is 1. Let's draw that triangle. So just a generic right triangle. Call one of the acute angles theta. Okay, where do I put the x? Opposite. So that's this vertical side over here. Where do we put the 1? That's the hypotenuse, that's there. Okay, turns out it's going to be useful for us to know what the other side of this right triangle is. What famous theorem can we apply? Pythagorean theorem. So Pythagorean theorem to figure out this thing right here. I'm just gonna, I don't know what I'm gonna do. I'm gonna erase this a in just a second, but I'll write up here. A squared plus what? X squared equals 1 squared. So I'm trying to figure out what a is. So let's subtract x squared. And 1 squared is just 1. And so what is a? Square root 1 minus x squared. Yeah. Square root 1 minus x squared. Agree? Hey, that's starting to sound like what you wrote on your quiz, right? Square root of 1 minus x squared was in your answer. Okay, so let's finish. What we were after here was 1 over cosine of inverse sine of x. But we just rewrote that as 1 over cosine of theta. So this problem hinges on us just being able to look at that triangle and figure out what cosine of theta is. Cosine is what over what? SOHCAHTOA? Adjacent over hypotenuse. Okay, so 1 over, that's just copying the numerator. Cosine becomes adjacent over hypotenuse. Adjacent is which side? Square root of 1 minus x squared, right? That's the bottom. Divided by, what's the hypotenuse? 1. That's it. You don't need to put that divided by 1 in your final answer, and you didn't on the quiz. So we've just proven that the derivative of inverse sine of x is 1 over square root 1 minus x squared. Okay, let's fill that in the blank here. 1 over square root 1 minus x squared. And every time we now have a new derivative rule, we apply the chain rule. So it becomes 1 over what? Square root of 1 minus the stuff. I'll put that in parentheses, squared. Right? Just change the x to stuff. But then at the end, times the derivative of the stuff. Again, that derivative of the stuff is always on the side, which means it's where, top or bottom? It's on the top. It's never on the bottom. Okay, we're not going to do the inverse tan formula, but you do the same exact process. And at the end of the day, you will get the formula that you memorized. So hopefully it's got some more meaning now. 1 over 1 plus x squared, you just memorized before, but at least it hopefully looks reasonable based on what we did with inverse sine. And then we can extend the inverse tan derivative rule with the chain rule. So inverse tan of stuff becomes what? 1 over 1 plus stuff squared. And then times derivative of the stuff. Okay, let's put our new derivative rules to use in number 7. It says find the derivative of the inverse sine of 5x over the arctan of x cubed. So you'll notice that I put a little -1 for the inverse on the sine function, but then I wrote arc in front of the tangent function. They are synonyms. I'm just making sure that you are clear that they're both exactly the same thing. Whether you do the -1 or the arc, they both represent inverse of the trig function. Okay, so equals. What is the fundamental rule on this one? That is a quotient rule. So, big old fraction line. I always like to put the bottom first so that I don't forget it. What goes on the bottom? Arc tan of x cubed, whole thing squared. Quotient rule says bottom squared, right? Okay, so now we apply the quotient rule upstairs. It says bottom times derivative of the top. So we copy the bottom. Times the derivative of the top. This is a brand new rule for us. It's one of the ones we proved today. So that is inverse sine of some stuff. So that becomes 1 over. Yeah, exactly. Yeah, f prime is what we're about to write here. I wrote my g first. It doesn't matter. Okay, so here's the f prime. 1 over square root of 1 minus x squared. So I copy almost all of that. 1 minus, but then it's not x getting squared. What's getting squared here? 5x. Notice the parentheses. Got to have them. On not the derivatives quiz, but the one before, which I handed back last class, a couple of us are forgetting the chain rule here. You apply the regular derivative rule correctly, but then you forget you always have to multiply by the derivative of the stuff. So we don't get to stop here. We have to multiply by the derivative of what's in the parentheses. 5. Small, but important. Okay, so that was the bottom times derivative of the top, or g times f prime, minus top, copy the top, inverse sine 5x, times the derivative of the bottom. So arctan, 1 over 1 plus stuff squared. 1 over 1 plus, what is getting squared? X cubed, right? 1 over 1 plus stuff squared. But it's not quite done. We haven't finished. Times 3x squared. That's the derivative of this stuff. I'm done. You can keep going if you want. I don't want you to keep going. Okay, that's it. Quotient rule, but inside the quotient rule, we had new inverse sine derivative and new inverse tan derivative. Any questions on either of those? Okay, activity is on the next page. Let's jump in.